4 tan theta, 4 secant squared theta d theta, square root of x squared plus 16 should be equal to 4 what? Secant theta? Right? Okay, and then rewriting the integral 1 over 4 secant theta dx is 4 secant squared theta d theta. Ah, this one's real clean. 4's cancel. You just get integral secant theta d theta. We good so far? And then that's just a formula, right? What is it? Natural log secant theta plus tangent theta. Let's see. And then triangle. Triangle at this point. Oh, do they have something in here? Hold on. Let's see if they have a plan.
No, you were here first.
Are y'all want to come in?
No.
Oh, okay.
Sorry.
Get the hell out of here. X over 4. X over 4. Right? 16. Yes? And then you can get all your information here. So natural log secant theta was root x squared plus 16 over 4 plus tangent theta, which was x over 4 plus c. Right? And then you can get a common denominator there. I mean, there is a common denominator, I should say. Right? So when you put those two together, you get natural log square root x squared plus 16 plus x all over 4 plus c. And bet you that's not the answer in the back of the book. It may not be. I bet you they have this. They might have that.
What about the force?
Exactly.
Why?
Well, you see how these went together, right? Right? And that's this. Okay, remember the natural log. If you have natural log and you have division inside of a natural log, you can turn it into what? Minus. Right? So this turns into natural log of the top minus what? Natural log of 4, but natural log of 4 is just a number. A number plus a constant is still a constant. So you don't even care what that is because you don't know what that is. I'm betting that's what they have in the back of the book. So just FYI. I want something more interesting, like number 53. Can we do 53? This will be the last one I think I have time for. So I'm skipping 51, 49, and 51. So I'm going to make a mark here. I need to come back 49, 51. I need 23, 25. Okay, so I need to do those. So 53. X squared over square root 9 minus 25 x squared dx. Is that right? Is that what's there? Yeah? All right, so the point of me doing this one is to illustrate something that's pretty critical here. And that's in the formats that we have, right? This looks a lot like this format, right? Except that, you know, the implication here is that that's a 1 in front of the x squared. We have a 25. So you can't deal with that the same way. Understand? So what we need to do, there's a couple of options on how to do this. Different instructors do it different ways. I'm just going to show you the way I do it, okay? And you might see something different, a little different. Some instructors will just make this right here a 5x quantity squared and then do a basic substitution first and rewrite the whole integral in terms of u. And then go do a trig substitution. All right, because this would turn into a u squared, right? But I do something a little different. What I do is I just force this to be a 1. So I factor 25 out. So I go like this. I'm going to factor 25 out, which means that this can't be a 9 anymore. It has to be 9 over 25. And then minus x squared dx. Do you agree that's the same thing? And then this root 25, since that's multiplication, can actually come out, right, as a square root 25, which is 5. Yes? Right, since that's times, I could break that into 2 roots, root 25 times root 9 over 25 minus x squared, right? That's the same exact thing. Then that root 25 on the outside is a 5. Had I factored out a 20, then I would pull out a root 20, because it's not a perfect square, but it's a constant, so it would just come out. So now what my integral looks like is this. 1/5 integral x squared over square root of 9/25 minus x squared dx. Do y'all follow that? No questions? You sure? Okay, so now at this point I can use the formula. It's a little tricky on what a is though. So the formula we're using, we're going to make a substitution. X is a sine theta. X is a sine theta. X is, what's a? 3/5 sine theta. So it's just the square root of that number. Square root top and bottom separately. Okay, Zach?
I was going to ask where you got the 5 from, but I realized it's because the 5 was on the bottom. So it's
5 was on the bottom, and then the square root of 25 gave us the 5. So dx is 3/5 cosine theta d theta. And our square root part that we have to rewrite, square root of 9 over 25 minus x squared will be equal to, this is where things get a little bit weird, 9 over 25 minus our x squared is 9/25 sine squared theta, right? That's what happens when we square this. I'm going to erase this, but y'all are going to have to remind me what it was, because that's the integral I'm going to be working off of, right?
9 over 25 minus x squared.
So, let's see, 9 over 25, then 1 minus sine squared theta, which turns into cosine squared theta, right? And then, I guess I'll just keep it here. So what is this? At the end of the day, after the root and everything. 3/5 cosine theta. Just remember that square root thing is going to turn into this. Do you have any questions on that? All right. So now I'm rewriting this equals 1/5 integral, x squared on top. So x squared for us is this squared, which is, what's that? No, okay, sorry, I didn't hear. 9/25 sine squared theta on top over the root part, which turns into what? 3/5 cosine theta. But then the dx part, which turns into, hey, is that right? Yeah. 3/5 cosine theta d theta. Right, this right here. That seems too nice. So I've got 9/125ths integral sine squared theta d theta.
You could always try halving.
Half angle?
Yeah, no, I was just kidding. I'm gonna get over.
No, that's right, but why do you call it half angle?
Just to spite you.
I think that's what you did on purpose.
And why is that? Oh,
What?
no, I see. 5 times 25 is 1
So, power reducing is what I've been calling it, but yes, that's the right way. Right, so I'm going to rewrite here 9/250ths, because the 1/2 is going to come out of that formula, integral 1 minus cosine 2 theta d theta. So that 1/2 brought it out. Are we good? Are we good? Yay, nay? Okay, so now antiderivative of each of those, right? So 9/250ths, antiderivative of 1 is going to be theta here. So Zach, you're going to have an inverse trig function here at the end. And then the antiderivative of this is going to be, what, 1/2 sine 2 theta, but then there's a negative, so negative 1/2 sine 2 theta, but then there's a 9/250. So how about 9/500? Minus 9/500 sine 2 theta plus a constant.
So we factor out the 9 250ths.
Well,
Theta plus, or no?
you could. What I'm going to do, because of the next step, what I'm going to do is I'm going to leave it, because remember this sine 2 theta is going to turn into 2 sine theta, 2 cosine theta? This right here, right? The 2 that comes out is going to reduce this back to 9/250. Right? This is 2 sine theta cosine theta. So that 2, which is on top here, reduces out and becomes back to a 9/250. Yes? Zach? No?
Absolutely.
We have 9/500
Times 1/2.
times, not 1/2, no. I'm saying this sine 2 theta is 2 sine theta cosine theta. The 2 is on top, right? And then 2 goes into 2 once, 2 goes into this 250 times. So it's 9/250. I just wrote it down here to show you what this is, but really the 2 is on top. So because of that, my next one is minus 9/250 sine theta cosine theta plus c. And I'm going to need a reference triangle. My original substitution was x was equal to, was it 3/5 sine theta? Was that it? Ooh, yeah, huh? What's what? What? Yeah, is that it?
3/5 sine theta.
Yeah. So we're going to make a reference triangle out of this, which is going to be a little weird. Because I'm supposed to divide both sides, right, by this number,
3/5 would be 5 thirds.
which is, yeah, so multiply both sides by the reciprocal, and it becomes 5x/3, right? That's the way you should probably do it. 5x/3. 5x/3 equals sine theta. So that means this is 5x, this is 3, which means this is the square root of what?
25x squared.
And then this one 9, so 9 minus 25x squared. Hey, wasn't that the original root thing? It was, wasn't it? Before I factored out the 25. All right, I think we're ready. This is 9/250 theta. What's theta going to be? Come back to this right here. Arc sine of 5x/3. Minus 950, or 9 over 250 times sine theta, which is 5x over 3, times cosine theta, which is root 9 minus 25x squared over 3, plus a constant. I think I'm going off my video here. And we have 9 minutes till class. We're almost there though. 9, that's 9 gone. How many times does 5 go into 25 to 250? 50 times? Can someone look in the back of the book? What number was this again?
53.
53. I've got 9 over 250 arc sine of 5x over 3 minus 1/50th x root 9 minus 25x squared plus c. Just going to see if that looks anything like the back. I'm sorry again, what number was it? 53? And 6.2? Oh, it was a definite integral. I don't have the answer. You'd have to plug in numbers, but I think it's good. We could always take the derivative, but we're out of time. Huh? All right. More of this to come.